we're going to talk about dummy variables, or as R calls them, factors. For instance, I'd shown plots about life satisfaction and various measures of people's, over their lifetimes, and they're very different for people with different educational qualifications. A dummy for education, or interaction, or factor, or moderator, or whatever you want to call it, would really help to model these. So a dummy variable takes a value of 0 or 1 depending on some logical condition. 0 false, 1 is true. For example, if we do an experiment where each subject is either in the treatment group or the control group, nobody's in both, everybody is in either one or the other. We could define two dummy variables. One, treatment, takes the value of 0 when that's false and 1 if it's true. And another dummy variable, control, takes a value of 0 for false, 1 or true. If you add those up, you'd get a list of 1s. So we could do either of two regressions. We could, or back off, say not even regressions, any comparison, but regression as a specific comparison. We could do a regression y is beta naught plus beta t treatment plus some error. Or we could say y is beta naught plus beta c times control plus some error. So essentially either I can compare the people in the treatment group versus the generic, i.e. the control group, or I can compare the people in the control group against the generic, i.e. the treatment group. So it doesn't really matter which one I choose, as long as I remember which one that is. But if I create a regression y is beta naught plus beta t treatment plus beta c control, then beta naught is left just hanging there. It's undefined. When the dummy variable is treatment, that asks how the control is different from the omitted category, and vice versa. But if you're to put in dummies for both, then those would try to estimate relative to the omitted category, but there's nobody in the omitted category. That doesn't work by logic, nor by math. If you tried to run that in R, it would automatically drop one of your dummy variables. It always helps to do the math for the dummy variables. I'm not calling you a dummy. Sometimes I call myself a dummy for not doing the math. Regression of y equals beta naught plus beta t treatment can be rewritten in two rows as y is beta naught plus the error if the person is in the control group, or y is beta naught plus beta t plus the error if the person is in the treatment group. So that just means, the impact is different by some factor if the person is in the treatment group. The regression would estimate beta naught as the mean of the y variables among the control group and estimate beta naught plus beta t as the mean of the y variables among the treatment group. Now, alternately, if we had a dummy if the person's in the control group, we'd write two rows, y is equal to beta naught plus beta c plus error for the control group, or y is beta naught plus error for the treatment group. Either way, the dummy coefficient estimates the difference in means between the groups. The sign changes depending on which group is the omitted group and which is represented by a dummy, but it's the same in absolute value. If you put dummies for both control and treatment in a single regression, then the mean of the control group would be estimated by beta naught plus beta c, the mean of the treatment group would be beta naught plus beta t, and I got two equations and three unknowns. So either I have to drop one of the dummy variables or estimate the regression without beta naught, no intercept term. You have to leave out something. And this all generalizes for dummy variables with multiple categories. If I have dummy variables for which of the 50 states a person lives in, I'd put in 49 dummy variables and omit one of those. Now R calls these factors instead of dummies. Probably is a better word. Dummy just sounds so whatever. But we've talked before, statisticians are lousy at naming things. Anyway, R will give you shortcuts. I'm kind of ambivalent about how much you want to be using shortcuts at the beginning. Sometimes you slide by without really quite understanding what's going on, and that creates difficulties later on where you want to diagnose where the problems are coming from. So eventually, you want to get to the stage where the shortcuts are valuable because you understand everything you're skipping over. But, maybe do it the long way at the beginning. For instance, if you have a set of dummy variables in education, you could have just one factor called education. That's a lot simpler notation. But R is still going to interpret that as split that factor into lots of dummy variables and do a regression with all but one of those. So that's, and again, you want to make sure that happens. Sometimes, in our creating graphs, we've slid back and forth. Sometimes a thing is a factor, sometimes it's a continuous variable, right? For graphing, sometimes education makes sense to try to treat that as a number, like years of schooling, and perhaps graph that as a number, think of that as a number, but want to remember, okay, to what extent are we actually keeping that in any particular instance as a number? So here's a simple example, looking at just 3 of the education codes. Person has a high school diploma as their highest educational qualification, or they have some college, or they have a college degree. So on the left, I show that's a factor with 3 levels. On the right, I show how that would be broken out into 3 dummies, right? A dummy for high school would have a 1 for somebody with that's their highest qualification, 0s for the others. A dummy for some college would have a 1 for that, 0s for others, etc. Now, if we have multiple dummy variables for different characteristics, we can look at the interaction or intersectionality or the moderators. And for instance, we might have dummies for education and whether the person is in the control or treatment group. And we might wonder, okay, how much does education moderate the impact of that treatment? So just multiply the dummies together. The dummies take the value either 0 or 1. 0 times anything else is 0. We only get a 1 where both dummies are true. 1 times 1 equals 1. 0 times anything else is 0. So a dummy for college degree interacting with a dummy for treatment group would have a value of 1 only for people with the college degree who are in the treatment. Everybody else, either because they don't have that degree or they're not in the treatment, i.e. they're in the control, would get a 0. And we'd interpret the coefficient on the intersection as the extra effect, plus or minus, to people who have both. If people with a college degree who get treated get even more out of the treatment, then the estimated coefficient would be positive. Don't worry, I know this is all confusing. We'll go through a whole bunch of examples.